Hello, and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Faulconer, and today I'm joined by Bjorn Ovick, head of Fintech at Skyflow, and we'll be talking about the privacy and security for payment processing. Bjorn, welcome to the show.
Hi, Sean. Great to be here.
Thanks. So I think one of my favorite things about hosting this show is I get to talk to a lot of really smart and very experienced people. And as sort of the audience is, hopefully learning from them, I'm also learning from the guests. And I think today is definitely no exception. Bjorn, you've probably forgotten more about the fintech industry, the payment industry in the last 30 seconds of my rambling than I'll ever personally know. So it's great to have you here and to help shed some light on this. But to start, can you please introduce yourself?
Yeah, Bjorn Ovick, again, oversee our fintech and payment business here at Skyflow. My background for the last 20 plus years has been in financial services payments. I've worked at companies like Visa, PayPal, Samsung Pay, American Express, and actually grew up at Wells Fargo when e-commerce was just starting, and we built out a lot of the first PayFac models and multi-seller models there. So all things payments and financial services.
Yeah, as you mentioned, you have a pretty impressive background working for a lot of sort of big name companies in the financial industry like Wells Fargo and American Express, Visa. The list kind of goes on, and even founding your own company at one point. Can you talk a little bit about sort of how you ended up actually gravitating towards that industry, and what was like your educational background that actually led to spending the bulk of your career in this space?
Yeah, it's interesting. I actually started out my first job out of college as an analyst for a big computer publishing organization, Network Computing Information Week, and so on. And our publisher actually at the time went over to a company called Netopia. And that's, I kind of fell into payments at that time. And this was, 99, 2000. And what we did is we sold server-side licenses to one-stop shop e-store, so website, e-commerce site, and payment abilities to large national banks. And literally fell into it by following the publisher over there where she ran marketing. And since then, learned a lot, and it's a great community, a lot of smart people. More importantly, it's fun to push the envelope and start pushing e-commerce and new solutions on e-commerce in 99, 2000, moving up to mobile payments, moving into all these new network tokens and all these new things from that perspective. So it's been great.
Yeah, we'll definitely get into some of those, newer technologies. E-store is definitely a term I haven't heard in a very long time. So thanks for dropping that. You also have over 20 patents related to payment applications. Can you talk a little bit about what some of those patents are and where they came from?
Yeah. A lot of that work happened while I was at Visa. My job there was overseeing innovation for our global processing group. And it was actually a lot of fun where, Visa has what's called VisaNet. It's a central processing hub that they use globally to connect, 90 million merchants with, 4, 5, 6 billion cardholders. And what I was asked is, what else can we do with this network? And it is old messaging. It all runs on the ISO 8583 spec, which it was challenging to say, okay, using this spec that works really, really, really well for real-time authorizations, how can we add additional value out to the merchant ecosystem, the consumer ecosystem, as well as other entrants into the financial technology and financial service space. And that's where a lot of those patents came out of things such as real-time redemption, doing things with the receipt data that's printed off or messaged to you, real-time messaging at time of authorization, all of these things that, things around network tokens as well. So all of these things that we're seeing come to fruition now, which is a lot of fun.
Yeah, it must be really rewarding to see this work that you did maybe at least a few years ago now actually being turned into something that is actually being used, has technology applied to it, and is serving, a variety of different purposes within the industry to make, payments better, make them more secure, what have you.
Yeah, absolutely. Absolutely. It was fun too, because I was there and then I left to co-found a startup called Staffly, which was a two-sided marketplace for staffing. And it was interesting because, again, Visa is a two-sided marketplace. You have sellers and you have payers. They call it a four-party model because you have banks jammed in between. But again, at Staffly, we're doing the same thing where we were accepting payments from our customers and then having to push those payments out to our employees, or what we called staffers. So it's just fun to see the different applications to two-sided networks and actually going out and building that as well.
Yeah, and that's something that you and I have in common, where we both started technology-focused staffing companies at one point in our lives. So today you're head of Fintech, business and growth at Skyflow. What does that consist of, and how did you actually come to work at Skyflow?
Yeah. So my job is really looking at the financial service space and seeing where there's application that's needed for what Skyflow does. As from a Skyflow perspective, we provide a data privacy vault. And when you look at the financial service payment fintech space, there's two sets of sensitive data. The first is PII data, so personally identifiable information. The second is payment data. And understanding in what Skyflow has from a centralized technology perspective, and then figuring out how to make that applicable into the financial service space, payment space, fintech space, crypto space, and so on. And that's my job in taking, again, our core, which is really, really strong, making some minor modifications, enhancements to it so it's applicable to the market, and then bringing it out to the masses there is my job here. And it's a lot of fun. And then going out and supporting our sales team and figuring out the best way to bring this to market and all that, and partnerships and those. So it's a great role. What brought me to Skyflow? So I've known Anshu for a long time. Actually, at Wells Fargo, I brought in Salesforce. He was at Salesforce at the time as Salesforce's first enterprise banking customer. And you can imagine what that conversation was like, going to my compliance team that has all of our customer data sitting on old mainframes and saying, I want to put it in the cloud, and just going through that. But Anshu and I got to know each other well at that time. And then when we put out the RFP to build Zelle at the time, he got involved from a Salesforce perspective there. And we've just stayed in touch ever since. And then when he told me about this, when it was still, it was more than a bullet point in his head, but it was starting to get some legs. Instantly saw the value. I could have used this at Wells Fargo, Skyflow's solution. I could have used this at Visa, and I could have used this at Staffly. So seeing the different realms from a pure startup all the way up to large, Fortune-sized companies, and the applicability of the solution was big.
Mm-hmm. Yeah, that's awesome. And, you touched on this a little bit earlier, and also, just talking about sort of this idea of, moving these existing banking systems that are running on these, on-prem to the cloud is probably, something that has been an evolution in our industry for, the past, 10, 20 years. And you've been working in particular in like the payment space for a long time. Can you, maybe talk a little bit about the evolution in the space from, where you started your career to where we are today from like a technology perspective?
Yeah, absolutely. So again, I shared about Natopia. We literally were, shipping off CDCs at the time with our software on it to load up on a server inside the mainframe systems at Citibank, Bank of America, Wells Fargo, and so on. So Wells Fargo then, when e-commerce, was taking off, we built out large multi-seller platforms, again, on mainframe systems. So at the time, eBay had BillPoint, and it was a JV between Wells Fargo and eBay, which again was the first iteration of what PayPal was. Then we supported PayPal on that same system and mainframe system, and then we added other capabilities on that system again, where you could have multiple merchants plugged in one pipe into the merchant processing ecosystem. The challenge there, though, was it was expensive to maintain and have these large data centers, all these boxes and machines up and running. And, the cost to do that, you had to have great scale to keep those systems up and running at that at the speed and the reliability they need. Fast forward to today. And it takes all that away by being able to move things to the cloud and instantly scale your infrastructure, both vertically and horizontally, as needed, depending on the demands against those systems and those applications, which is huge. Are there challenges with it? Absolutely. There's the old guard and the new guard from a data security perspective, where a lot of times this is the way we do it and the way we've always done it. From a banking perspective, which a lot of times I'll bang my head against the wall having those conversations, or in the past I have, versus no, this is where the future is. We got to get there and got to go do this. And when you start peeling back the onion of what those actual concerns are, and you get outside of the hard-headedness of this is how we've always done it, and start digging into, okay, what are the reasons that you're concerned about moving this to the cloud? And you can start to really have a good conversation about that and get folks comfortable with this happening, not only from a similar security posture, but also the value add and the new benefits you can build on top now and move a heck of a lot faster. And do a lot more iteration quickly, a lot more testing quickly, and cost effectively.
Yeah, in a recent episode where we talked to some folks from Google Cloud about building secure CI/CD pipeline. One of the points that they made in terms of transitioning the cloud from sort of on-prem is besides the scale that you get, in some ways it actually makes it can make privacy and security easier for companies, because you're kind of offloading some of that to the public cloud, and as long as those systems are set up in a way that best practices are enforced, and you can kind of take some of that responsibility off your plate. And of course, there's definitely things that you have to be thinking about. The scale of a mishap at the cloud when you're scaling worldwide, of course, that impact can be massive. But there is a lot of advantages for moving to the cloud, just even beyond sort of the vertical and horizontal scaling that you get, even from a sort of privacy and security perspective.
Yeah, absolutely. And there are things that will never, I never say never, but would be a far stretch to move up to the cloud, right? When you look at VisaNet, its large authorization platform, when you look at what MasterCard does, when you look at the clearinghouse that's moving trillions of dollars every night, or the Nacho Rails moving, trillions of dollars every night, will this be in the cloud? Not anytime soon, but never say never, right?
Right. Yeah. So I want to transition to talking a bit about, payment processing and payment systems. And I think it's hard to talk about payments without touching on, PCI DSS. So what is PCI DSS? Where did it come from?
Yeah. So PCI came from the Payment Card Industry Council, I think is what it is. I'm not quite 100% sure there, but it was an association created by the network. So Visa, MasterCard came together and created this association to come up with guidelines of how to protect card data from fraudsters, essentially. And it came up with a number of different guidelines to do that, both for what is called a card present payment, meaning I'm present to give my card or tap my phone at a point of sale, or card not present, where it is done behind a computer or through a screen or an app to them. And there's different guidelines around that. But ultimately, it was to come up with guidelines, as well as a framework to certify that you are upholding these different PCI guidelines.
And how does a company go about achieving, essentially PCI compliance?
Yeah, and there's two facets of it. When you look at the two sides of the network, right? You have PCI guidelines for what are called issuers, or people that are issuing the card number or cards out to individuals or companies. There, the guidelines, there are two different levels of PCI compliance: level 1 and level 2. And what it entails there is it's cut off based on the number of transactions or cardholders you have, to either be level 1 or level 2. Level 1 is the highest level of PCI compliance. There's a checklist of 400 plus controls that are looked at, looking at your technology. Are the cards encrypted if they're stored? Are the cards encrypted in transit? All of those types of things, key rotation, whatever it may be from that standpoint. It also encompasses policies of the company as well. So, for example, I'm an issuer in my customer service team. I have a policy where they should not write down a 16-digit card number on a Post-it note. Because again, that's not a secure way to do it. So it's full encompassing, the two spectrums of what that compliance looks for. Level 1 is you have to go in and obviously set up your own systems and run through that, and then bring in an auditor that will then come in and audit all 400 plus of those checks around that. And it's a quite extensive process, from start to finish. 3, 6, 9, 12 months, depending on your posture. So that's level 1 for issuers. Level 2 is a self-assessment. Again, the exposure is not as big because it's lower amount of cards and lower amount of transactions. So the exposure is not as big if there is, they don't need to have the audit come through if there's a breach or those things, but they still need to self-attest that they are doing all of those things. And there are questionnaires that you can go through and go through that self-assessment or attestment yourself, and come out of that with your level 2 compliance. Switching gears then to the merchant side, and the merchant side is actually where more fraud has actually happened. And this is where bad actors will breach and get card data. And there's 4 different levels of PCI compliance, level 1 through level 4. Level 4 is a small business, selling, a couple $1,000s a week, if not more, out of, think your local mom and pop shop, all the way up to level 1, which are large retailers doing 6 million transactions or more. And again, it's a similar process where level 1 audit full extent, moving to level 4, 2, 3, and 2, different levels of self-assessment, as well as network scans at level 2.
And in terms, you mentioned, for something like PCI level 1, there's this external audit that's happening to make sure that you're actually doing the things in the checklist. Who's that? Where's that auditor come from?
Yeah, there's an industry around PCI auditors today, and there's some big auditors out there that do this, that are experts in that space. So card merchants or issuers or anywhere along the value chain will hire an auditor, and come in, and the costs range from $20, $50, $100,000 to get that audit done. Again, depending on what their infrastructure looks like and what they need to look at. And there are different ways to go about getting PCI compliance, looking at the merchant side. A small business today is single threaded, meaning they work with one merchant processor. That merchant processor will provide, as part of their service, a complete PCI compliant solution to them from a technology standpoint. They'll also provide policies to them of what they can and cannot do with the card data from a policy perspective. And then in those cases, the merchant will go in and do their self-assertion to say that they're doing all of these things, and they've implemented the merchant processing solution the way that they told them to, and they're done and fat and happy, and move on to the next fire that the small business has to deal with. Moving up to level one, there a lot of times they will work with multiple processors or have different needs for that card data outside of just processing payments through one payment processor. A lot of times they will set up and build out their own PCI infrastructure that needs to be compliant. And that's really complicated and complex to do. And again, the auditor will come in then and look at the 400 plus checks and go through it line by line, asking questions, observing, looking at code, checking, policies around key rotation as an example. And it's an extensive process to do, number one. Number two, it's super expensive to build as well, and maintain.
Right. And so if someone buys essentially technology that's already, PCI compliant, there's still a responsibility on the purchaser or the merchant in this case to do the self-assessment and show that they actually are following, the best practices and policies of PCI. Is that right?
Yes, that is correct. That is correct. And, as example, we work with merchants across the board, level 1 to level 4, and we actually provide that capability as part of our service to them. But they'll come in, and depending on what level they are, they'll answer, 15, 20, 40 questions and go through that. And if they've implemented Skyflow, for example, or if they're using Stripe or, authorized.net, it's the same process. They'll come in and answer those questions with their service provider and get that assessment and certification done.
Mm-hmm. And if someone does the self-assessment, they, become compliant, but it turns out that they are indeed, copying, 16-digit numbers down onto Post-its or, some other type of violation. Essentially, what is the sort of consequence of a violation?
So it's across the board. When you look at some of the large breaches, what happens is the acquiring bank or the bank that owns that relationship with the networks will levy fines to those merchants, ultimately being dictated or directed out of the network itself. So Visa or MasterCard, if there's a large merchant breach, and they find that there were vulnerabilities or people weren't following PCI compliance, they will levy fines for that to get it fixed. Or if they're out of compliance, levy a fine until it's fixed. So there are financial penalties. The other thing is when you look at those large breaches, there's I call it the Wall Street Journal, New York Times damage that happens as well. Having that front page headline from a brand perspective really hurts. From a branding, trust of your customer standpoint as well. So that's what happens if you're not compliant. You could be fined, and ultimately you could be shut off from accepting payments.
Hey there, Sean here. I hope you're enjoying this episode of Partially Redacted. If so, please subscribe so you can always check out the latest episode and help others find the show by leaving a rating and review. Final thing before I get you back to the interview. If you're interested in privacy and security, have a challenge or issue you want to discuss, or want to share your expertise, please join the Partially Redacted community at skyflow.com/community. All right, now back to the show.
And then in the situation, you mentioned how complicated building out, essentially PCI compliant infrastructure is. What, from a technical standpoint, would actually, if someone wanted to take that on, how long does that take a company to do, and sort of what level of expertise do they need to actually, sort of build out that infrastructure?
Yeah. They're, breaking it out into 3 components, maybe 4. The first is, capturing the data securely And this is for card not present payments, just to be clear. So when a customer is entering their card data into your mobile app or your website or whatever it may be, you need to be able to capture that data securely, and having the right security metrics and certificates behind that data. So when it is captured, it's sent directly in an encrypted fashion coming in. The second piece then is, where is that data landing? And building out an isolated environment just for PCI is a best practice, and having that data be there and live there, and it needs to be encrypted as well from that standpoint. The other thing then, and the third component, is you need to use that encrypted data then. And what does that mean? You need to send it off to your processor to actually run an authorization and see if the card's good and not. So you have to build all of that connectivity out to the processors, again, using the various protocols that they have to secure those pipes the processors dictate. And then the fourth piece is, you need to also have access to that data. So for example, when I'm on Amazon, I have 3 or 4 different cards loaded on Amazon. I need to see those cards through my portal on Amazon, my customer portal, and they need to be able to show those to me. And a lot of times they'll show the last 4 of that, but building out that whole reveal aspect as well, having secure pipes to do that. The other use case is customer service may need my card number, saying, hey, I need to issue a refund, Sean. Should I issue it to your card number with the last 4 digits of 1, 2, 3, 4? How do you expose that card data in a governed manner to the folks that need it is another use case and something that they need to think through and build. I'm glossing over this at a very high level. There's more details to the ins and outs of the infrastructure and those things, but it is complex.
Yeah, for sure. It sounds like, something like just securely storing the credit cards is really just the tip of the iceberg in terms of this this long tail of things that you need to be dealing with. And then there's the issues like a card rejection that you need to be able to handle, and expiration of a card, and then all the use cases that you mentioned of how do you reveal some portion of the card to a certain type of user and so on. So it really starts to build up the number of things that you have to kind of build and maintain and take care of.
Yeah, and we didn't even touch on chargebacks, which is another complete animal. But yeah.
So obviously, it doesn't make sense for a lot of businesses that want to do payments to build out their own, PCI compliant infrastructure. It's a lot to take on, especially if it's not, the company's core competency. So how do companies that want to take payments typically go about, essentially getting PCI compliance, but not having to build out all that infrastructure, but still are able to actually execute and charge credit cards?
Yeah, so the journey that I've seen and we see all the time is I set up and I get going and I work with one processor, and that processor is a one-stop shop for my entire environment. So they will give me the ability to tokenize and vault cards, as well as process those cards through them. They'll give me secure SDKs and iframes to capture the card data. They'll give me secure, SDKs and iframes to reveal the card data through my app and those things. So it's a one-stop shop for those. And companies like Stripe, checkout.com, authorize.net. There's a whole PayPal, Braintree, a lot of different service providers or PSPs, payment service providers that provide that in the US and globally. So that's step one. What we see, though, from a pattern perspective is that's great. But merchants, payment acceptors, gateways, whoever it may be in the e-commerce ecosystem, mobile payment ecosystem, outgrow a one single-threaded processor. And they outgrow them for a number of reasons. And it all comes down to driving more revenue, both top line as well as bottom line. The first is I want to launch a new market. I'm selling today in the U.S. and I want to launch Western Europe, for example. I use Stripe today here in the U.S., but I want to use the PSP Mali in Europe. Now, what am I going to do? Am I going to have 2 different checkout flows? One with Mollies and one with Stripes? No, this is where companies like Skyflow come in, and we will provide a centralized vault to them where you can route payments out to the various PSPs that you may have. So global expansion, one, entering a new market. The other is reliability. So, if I'm processing millions and millions of dollars or transactions a day, and I'm reliant on one processor, what happens when those lights go off? I'm out of business. So also having a failover behind that as well is important. The third is, payment cost optimization. Different card types have different rates that are negotiated as you move up from a volume perspective with different providers. You will pay different rates, so you can optimize where cards are being routed to from a cost perspective. Moving along that realm, you also can route based on approval rates. Some processors have better approval rates for prepaid with certain banks than others, maybe debit cards. So you can optimize routing based on card type as well. And then the last is really cost savings, being able to have a unique vault yourself and being able to go as a merchant and negotiate amongst various processors to get better rates ultimately as well.
Yeah, so you get sort of that negotiating power by having that flexibility to essentially work with multiple payment processors.
Yeah. For me, it really comes down to, everyone talks about, credit card processor lock-in. Credit card processing lock-in is fantastic if you only need one processor. There's, and you should work with that. It's when you outgrow that and you want to have that flexibility to drive more revenue. It's not a lock-in. It's how do I expand my business? How do I optimize my business? And that's really where, vaulting comes in to be able to do that.
Mm-hmm. And is there ever, if you have a business that's doing a lot of transactions, is there an advantage for them to go directly to, say, like Visa and using Visa APIs versus using, a third-party payment processor that essentially does the connection to the Visa or whoever card network that they need to send a transaction through?
Yeah, so it's interesting. So Visa, we'll pick on Visa here, but networks have, Visa and MasterCard have what's called a four-party model. Which means that there are four parties involved. The only way that I can process a payment through Visa or MasterCard is I need to have a bank sponsor. So in bank sponsors are the only members of Visa's network to do that. So historically, bank processors also had their own processing platforms or went out and licensed those. Is where this started and where it happened. And then from there, banks have also licensed their sponsorship. So they will sponsor Stripe. Stripe's not a bank. Stripe has banks sitting behind them that have sponsored them to have access into Visa and MasterCard to process payments. With that said, Visa and MasterCard both are starting to open up direct access directly to their network, which is fairly sticky, right? Since if I'm a bank and I'm the one taking all the risk, I also want to take a part of that processing revenue as well and not have it just, licensing out my sponsorship. So it's interesting to see that starting to happen in the ecosystem and, the networks opening up direct access to different players in the payment ecosystem there. But again, ultimately, the sponsor bank is the one that you need to work with to be able to process payments with them. As far as going to your question around benefits, if I go directly into the network as a merchant acceptor, as a merchant itself, there are a whole bunch of things I have to build. Reporting, reattempts, chargeback management, the list goes on and on and on. And there's where the processor gateways airdrop solutions in for you to do that. You don't have to build it.
Yes, that's a big task to take on. So unless it really is going to make a difference to your business, and
there's no reason to do it. I mean, there are a lot of really good solutions out there to do it. And if I, when I had a team of engineers at Staffly, it's like, do I want them to focus on building out, all those processing capabilities, or do we just use, a payment processor and gateway that already have it? and deploy my resources to go out and build new capabilities and features for our customers instead of focusing on their infrastructure stack or payment stack.
Exactly. So if I'm a business that's working, with Skyflow, or I'm working with one of these payment processors, and the payment processor is in charge of, collecting the card details, charging the cards, essentially, what is the processor or Skyflow giving me in return so that I can actually perform sort of transactions against the cards without me seeing any of the details and sort of being exposed to the PCI compliance scope?
Yeah. So, I always steal the phrase shift left, and there are a couple meanings in that and data privacy standpoint, but shift left in payments means that the further you can move and isolate your environment from actually seeing and touching card data, the better you are. And that's what happens from a vaulting perspective. So step one is the SDK and iframe to capture it directly when it's entered, then landing in the vault, and then being able to send that payment to wherever it needs to go and orchestrate that payment from a Skyflow perspective between multiple payment processors on behalf of our customers. And that's what we do, and we do very well. And more importantly, we give control to our customers to actually own those API integrations with their payment processor. So they're not relying on us. We're giving them the keys to the kingdom to drive their business and do what's needed instead of them, ultimately relying on us. Where what we do is we focus on what we do really, really well, which is protecting sensitive data, and then governing or giving governance tools to orchestrate that data in a highly controlled manner. And that's our expertise in what we do, where they're going to have a better understanding of how to route that payment. They know their business than we ever will, and I won't pretend that we will know their business. So we're giving them the keys to do that.
Mm-hmm. Yeah, makes sense. And, there's been a lot of development, I think, in, the space of trying to reduce fraud, improve, privacy and security around the collection and use of credit card information. And, one of those things that you mentioned earlier, which is network tokenization. And this is something that is starting to become more and more, prevalent in the industry. How does network tokenization, improve security, improve privacy? And I guess maybe a good place to start with that question is, what is network tokenization?
Yeah, absolutely. So network tokenization was introduced a few years back when Apple Pay launched. And Apple Pay gives you the ability to tap your phone at a point of sale, and it passes over your payment credentials, your card number. Everyone thinks it's your card number, to the point of sale, and then they process it like they normally would. What's happened though is in partnership between Visa and Apple is your card number doesn't actually sit in your phone. What has happened and what was built was the ability to provide a token that translates to your card number that actually sits in the phone. And as that token then travels throughout the hops to get to Visa, Visa says, oh, this is Sean's token. Let me exchange that for the actual card number, the PAN, and then send that off to the issuer. And the reason that came out, and it's important, is it reduces the scope of the actual card data and the vulnerabilities of all those hops getting to the network to be stolen or compromised. So this happened starting out with the wallets. So Apple Pay, Google Pay, and Samsung Pay all support this protocol today. The other thing that happened around that time, or actually happened before that, was EMV was being rolled out in Europe and was widely adopted. And in the US, it was starting to be adopted and incented to be adopted by the networks 5, 6, 7 years ago. And so what's happened with EMV is it's a much more secure transaction for card present transactions. You dip your card or insert your card into the point of sale, and a cryptogram is actually created at that time, a one-time use cryptogram that's sent to the network. So it's completely cut back on fraudulent transactions for card present transactions. So what happens? All the fraud shifts to card not present because there's not as great of security there. More recently, the networks have introduced network tokens for card not present payments. And this is something Skyflow provides. But now when I enroll my card to be stored with a merchant for recurring transactions or card on file, we go and get a network token for that in our vault. And now instead of sending through the card number, we send through from end to end up to the network the token, which is step one of that. Step two, for every authorization, there's also a retrieval of a cryptogram. So again, it's a one-time use cryptogram that's associated with that merchant, with that cardholder, with that specific transaction. So fraudsters are stuck because of that cryptogram, and it's a much more secure payment around that. So what we're seeing there is three benefits. One is increased approval rates. So if I know this is a network token transaction as an issuing bank, as well as Visa, I'm going to approve that, more likely approve it because it's less likely to be fraud. Step two, so you have higher approval rates. Number two, you have lower fraud because it is a more secure transaction. And then number three, Visa's introduced interchange relief. So on average, it's 10 basis points less to process a network token transaction versus not having a network token for that auth, which will save a lot of money for merchants as they go down this.
So yeah, so it sounds like, besides the sort of business benefits of it from a security perspective with network tokenization, you're getting the benefit of essentially, swapping out the card number for something that's non-sensitive, essentially a random string in the form of the token. But with network tokenization, you're reducing the number of hops in the network where the actual card number is ever shared. So it reduces the essentially the attack surface, potential attack surface. Is that right?
Yep.
Yeah.
Yep, absolutely. And in the U.S. market, it's coming out. India introduced legislation, RBI legislation, where they're mandating all cards to be removed from the ecosystem, and everyone has to use card tokens or network tokens to do it there. So it's not just a U.S. or Western European phenomenon. It's happening globally, and governments are stepping in to mandate it.
Yeah, and it sounds like with also the addition of the cryptogram, then even someone somehow got a hold of the token and was able to call the APIs, they still can't really do anything with it because they would need to be able to generate the one-time cryptogram associated with the actual transaction.
Exactly.
So another technology that is starting to also become more prevalent in the payment space is 3D Secure. So what is 3D Secure, and can you talk a little bit about what that does from a security and privacy perspective?
Yeah, so 3D Secure, 3DS, was introduced in Western Europe mostly to start, and it's much more prevalent there than here in North America. What it is at time of card enrollment or time of purchase. So it's one thing, if I took your card, Sean, I could enroll that in, store it on file, and get a network token associated with it. How do I stop that from happening? So what they're doing is 3DS is a protocol now to validate that when you enter that card number into a merchant's website or an app, they're doing a number of checks behind the scenes to make sure that actually is you, Sean, entering that. If they're not able to do that discreetly, they have a challenge process then where they will actually direct you to log into that account. So, I have a Chase card, I have a Wells Fargo card. If I use my Chase card, it will actually have me log into my Chase online banking or Chase credit card account to authenticate myself and make sure it is me. So what this is doing, 3DS, is it's literally stopping or preventing fraudsters from just enrolling, stolen cards in there, because it's another layer of authentication to do that.
Yeah, it sounds like it's almost like a 2FA, but for payments.
Yeah, exactly. And 80, 85, 90% of the time it's done discreetly. So, device fingerprinting, patterns, IP address, all those things, that I don't have the ins and outs of what they're doing, but they're doing a lot of these checks discreetly before they'll do the actual challenge itself if needed.
Yeah, there's been amazing amount of sort of like technology and research and innovation that's gone in the payment world to prevent fraud from the AI that's used to detect a credit card transaction that looks different than a regular credit card transaction that I'm doing. Like I'm often amazed at the alerts I get where essentially somehow my card got out somewhere and I get an alert where a transaction happened and they catch it. A lot of the times it's really, really amazing the amount of innovation that's going on.
Absolutely. A funny story about that. When I was at Visa, we were testing out the ability to send alerts when your card was being used. And I was part of the pilot program there. And my wife and I share a card. And at the time she was at home with the kids. And every time she made a purchase, I would get a text message. And I laughed. I said, either this can give me a heart attack or cause a divorce, because it's like, you just bought what at Nordstrom's? In those things. So it was pretty funny. But the technology sure has advanced there, which is great. One other thing with 3DS that's really important is if and when this card is validated or the user is validated, there's what's called a liability shift for that transaction. So if that is a fraudulent transaction, the liability for that transaction is actually on the issuer now and not the merchant, which is big. Because today, for all fraud, or historically for fraudulent transactions, the merchant ate the entire cost of that when a chargeback comes through, which is very painful for merchants to have happen.
Yeah, for sure. So, kind of turning our attention or thoughts to, innovation in this space, where do you see, what are the, I guess, like big gaps or problems that the payment industry payment processing industry needs to try to address? And where do you see payment technology going in the next, 5 to 10 years?
So from a payment standpoint, again, it's continuing to improve the validity of the transaction and making sure that, as payments continue to evolve and become faster, there are more touch points or entry points for payments, whether it's a connected device now or your car, those things is continuing to ensure that the fraud is in bay, that the networks are opening up. As far as where it's going, again, when you have one centralized network connecting 90 million merchants to billions of unique IDs or cardholders, there are vast different use cases you can do with that network. Whether it's pushing payments, OTC payment, right in the debit rails to now push money in real time from account to account, to all the connected devices out there. I pull up into the gas station. There's some fun stuff we worked on at Visa. Is I pull into the gas station, the pump knows who I am. I get out and fill up my car, and that's done either from a connected car or me as an individual there. Or I pull up into the drive-thru. They know who I am, and my car is now a connected device. At Samsung, we did some stuff with Samsung Pay with smart refrigerators. It's like, hey, you're 3/4 of the way out of milk. Let's put a new order in milk, and the milk shows up and charges your Samsung Pay account overnight from your Samsung refrigerator. Building out this whole ecosystem of connected devices, but having the payment happening behind the scenes, and it's a seamless experience across the board from a frictionless standpoint.
So because there's a lot of innovation going on in the space, and also a lot for even someone who's handling credit cards to kind of get up to speed on what their responsibilities are, what would you suggest someone that wants to kind of stay on top of these things? What resources should they seek out where they can learn more and keep up to date on the innovation going on?
Call me. No, I'm just kidding. No, I love talking about this stuff too. And we have a lot of really good engagements sharing this. There are a lot of different resources out there, from payments.com to see some of the latest and greatest trends. There's some great conferences out there as well. There's a lot of podcasts around this. And it really depends on what angle you want to look at. Is it the regulatory side? Is it the technology side, the security side? There are a lot of different resources out there to stay up to speed.
Great. Bjorn, thanks so much for coming on the show. It's always a pleasure to chat with you. And I said it at the top of the show, I get to learn so much from talking to guests like yourself. So thanks again. And I'm sure, the listeners are going to learn a lot as well.
Thanks, Sean. It's been fun.